I'm Mr. Kangas, and today we're going to take a look at Chapter 4, Section 3, Greatest Common Factor. And specifically today we're going to be talking about how to factor an expression. You'll see this on the worksheet. On the practice sheet, you'll see this starting on question 19, factoring expressions. So when I say factoring an expression, I'm talking about something like 39b plus 84. So when you factor something, you're typically trying to figure out what multiplies together to get you that something. So what we're going to do in this situation, since we want to get an expression, we want to figure out what multiplies together to get us this expression. We're actually going to have to kind of do like a reverse distributive property thing, because what happens with distributive property is you take the number on the outside and you multiply it by both numbers inside. So I'm going to do a times b, and I'll get one of my numbers, plus a times c to get one of my other numbers. So I end up with an expression of this product plus this product, which is what this is. Okay. So what I would like to do then is figure out how I go from the expression back into the distributive property, where it came from. So the key thing you have to realize here is that a, on the number on the outside, goes into both of these numbers that you get in the expression. So a should go into both 39b and 84. So what I'm looking for here is the greatest common factor of these two numbers. That will be my a, because the greatest common factor will go into both of these numbers. So, I'm going to put this over to the side so we can remember what it is we're trying to do. Okay. So, first thing you're going to do is find the GCF of these two numbers in the expression. So we're going to do our factor trees. Okay. 39b actually ends up being a pretty small prime factorization of 13 times 3 times b. 84 not huge, but a little bit bigger. We have 2 squared times 3 times 7. So you're going to find what these two numbers have in common, which in this case they share a 3, and that's it. So our greatest common factor of these two numbers up here is a 3. So 3 goes on the outside. 3 replaces the a. So now we have to figure out what b and c would be. So to do that, you have two options. The first option I'm going to talk about, I don't necessarily suggest, but it is something that's possible. You can take a look and you ask yourself, 3 times what will get me 39b? So you know 3 times 13 is 39, so you'd put a 13 here, times b. 3 times 13b would get you 39b. Then you say 3 times what would get me 84? Well, if you took a while to figure it out, you would eventually come to the conclusion that 3 times 28 is 84. Now that can take some time to figure out, and the bigger and more complicated the numbers are, the harder that method is to use. Okay, even on this problem here, which isn't an easy problem, but it's also not one of the hardest problems, it could take many people several minutes to figure out what goes inside. So what I would do is, since 3 is your greatest common factor, okay, that means 3 goes into both of these numbers, which means that 3 is somewhere in the prime factorization of both of these numbers. Because if you recall correctly from the last video, we talked about how the prime factorization of a number will get you all of the factors of a number. Okay, so the prime factorization of a number can get you every single factor of a number. So no matter what factor a number has, you can create that factor with the prime factorization. So for example, in both of these numbers, I know that the GCF is 3, so I know they both share a prime factor. I know they both share the factor of 3, so I'm going to cross that 3 out. of these, and what's left will actually be what goes inside the parentheses. Because now that I've taken the 3 out, okay, what's supposed to happen with prime factorization, and I'm going to do this with a different number for a second here. We're going to pause. We're going to take a look at the prime factorization of 12, because I think doing it with a simpler number will make more sense. Okay, so the prime factorization of 12 is 2 times 2 times 3. Okay, and so what is going to happen here is, for example, if I wanted to know what do I multiply 4 by to get 12. Well, I can go up to my prime factorization, find 4, take it out, and what's left should get me the number I multiply 4 by to get 12, because when you write the prime factorization out, all these numbers here are supposed to multiply together to get you an answer of 12. These two numbers here for 39b, if I look at the prime factorization of 39b, if I multiply all these together, I get 39b. Okay? For 84, if I multiply 2 squared times 3 times 7, I get 84. Okay? So if I multiply all of these together here, I should get 12. So if I say what times 4 is 12, well, let's take out the 4. 2 times 2 is 4. Take that out. What's left? 3. 4 times 3 is 12. Why? Because I took the 2 times 2, turned it into a 4, and took it over here. What's left is 3. When I multiply 2 times 2 times 3, I should get 12. So 4 is 2 times 2. So when I take this 4 and I multiply it by 3, I should get 12, because 2 times 2 times 3 is 12, so 4 times 3 should also be 12. Other thing you could do with it, let's say I wanted to know, what do I multiply by 6, okay, to get 12? Well, here's my prime factorization. I know that 2 times 2 times 3 is 12, and I know that the prime factorization will get me all the factors of 12. So since 6 is one of those factors, I know I can get 6 somewhere in this prime factorization. I can get it right here. 2 times 3 is 6. So take the 6 out. What's left? 2. 6 times 2 is 12. Okay. We can do one more here. Okay. If I want to know 3 times what is 12? Okay, again, prime factorization. All of this is supposed to multiply together to equal 12, so if I take a piece of it out, what's left is what I need to multiply that piece by to get 12. So I'm taking the 3 out. What's left is 2 times 2, which is 4. 3 times 4 is 12. Or if you want to do it the long way, 3 times 2 is 6, times 2 is 12. So, how that applies to what we're doing over here. Okay, if I want to know what goes inside, well, GCF is a factor of both of these numbers. Okay? So what I am literally doing is I'm asking myself, 3 times what is 39b? Let's take a look at 39b's prime factorization. I know 3 has to be in it somewhere, so I'm going to take it out. What's left? 13b. So 13b goes there. Let's take a look at 84's prime factorization. Again, 3 is a factor of 84. That's why it's on the outside. It's the GCF. It goes into both of these. It's the biggest number that goes into both of these. So the prime factorization of 84 is 2 times 2 times 3 times 7. Okay, let's take the 3 out. Now we want to figure out what 3 times what is 84. So you take the 3 out. What's left should be what you multiply 3 by to get 84. So 2 times 2 is 4 times 7 is 28. To me, that's a much easier way to figure out what goes inside, because it's basically given to you. All you have to do is a little bit of multiplication, and there's no guess and check. So this is the way, if you are in my class and you're showing me this work on a quiz or a worksheet, this is what I want to see for work. I want to see the factor trees. Okay? I want to see the prime factorizations listed out. And I want to see the work that it takes you to find the GCF, but I would also like to see the work it takes you to find out what goes inside. Okay? So what I would need to see, we'll do another problem right from the beginning so I can show you all the work that you'll need to show me. Okay. If we do, let's go with 54b squared plus 81b to the fourth power. Okay. Prime factorization tree. Okay, so we're going to do the factor tree for 54. And we're going to do the same thing for 81. And I'm going to write out their prime factorizations. Make sure you include the variable if it has one. Okay, so at this point, I'm looking to figure out what the greatest common factor is. I want to know what is that A, what goes on the outside of these parentheses. So I'm going to take a look at their prime factorizations, figure out what they have in common. It looks like this one has 3 threes, this one has 4 threes, so they share 3 threes being multiplied together, so I'm going to circle that. They also share some B's. This one has 2 B's, this has 4, so they share 2 B's. So the greatest common factor of these two numbers would be 3 to the third power times b squared. So I'm going to write 3 to the third power out. And so 3 times 3 is 9, times 3 is 27. B squared just stays as b squared. So on the outside you have 27b squared. Okay? Now we want to figure out what goes inside the parentheses. Okay, so again, we're going to write out their prime factorizations. Okay, so I've written out their prime factorizations, but now what I need to do is remove the 27b squared from each prime factorization, and that will tell me what goes inside the parentheses. So if I want to know 27b squared times what will get me 54b squared, I've got to go up to 54b squared's prime factorization, remove the 27, remove the b squared, and what's left is 2. So I know that 27b squared times 2 will get me 54b squared. Now I need to go up to 81b to the fourth power prime factorization down here and remove the 27b squared as well. So 27 is the same thing as 3 times 3 times 3. So 3 threes. This has 4 threes. So I'm going to remove 3 of the 4 threes. So instead of having 4 threes, I'm now going to have 1 3 here. Instead of having 4 b's, I'm removing 2 of them because 27b squared has 2 b's. So I'm going to remove 2 of the b's. And what's left is 3b squared. So I know that 27b squared times 3b squared will get me 81b to the fourth. Okay. This is a very complicated section that can require a lot of work. I expect to see all this work on each problem like this. Okay? And you're going to want to try to keep it as neat and organized as possible. And if you're getting questions wrong or you're getting stuck, please ask me for help. And if you don't understand this video, ask a question. This is one of the most problematic sections that I have with my students. So make sure you pay close attention, took good notes, and you're asking questions if you need help. Okay, this is a tough section, and this is a different way to think about GCF than what you're used to. It's a little bit more complicated, but once you get it down, it's actually a lot quicker and easier to do. So that is all I have for you on 4.3, greatest common factor. Tune in for the next video on Chapter 4, Section 4.